dispersed heat. It is not very efficient for doing work, but it's still energy. Like I said, that energy has to go somewhere because it's got a bunch up here on the top when it's on the cliff. And you're right, John, it decreases as it goes down. But still, then when it hits the ground, that energy still has to go somewhere. But it moves out away from it. Energy is critical to understanding the world, but it is insufficient. A key missing element is entropy. Anybody ever heard the word entropy before? It's a new word? I feel like it would probably be a new word for it. Entropy is a measure of the amount of energy which has been dispersed, so it is not readily available to do work. So it's the measure of the amount of energy which has been dispersed, that energy that goes out, but it is not available to do the work. So it's not like, that's why I said, it's not like it makes the ground hot, or it's not like you feel the heat from the rock. It just spreads it out. It's there, but it doesn't really make a difference to that rock. Because energy isn't destroyed or reduced, it's just spread apart. Energy stays constant, but entropy increases with time. Energy disperses, spreads out over time, and becomes less useful for doing work. So the amount of energy available to do work declines with time. Oops. Can you use the concepts of energy and entropy to explain what happens when the rock falls off the cliff? Just think about this. Oh my word. Apparently popular. Okay, let's think about that. The concepts of energy and entropy to explain what happens when the rock falls off the cliff. Got the energy. What is the entropy? Let's back up if you don't remember. Oops, going the wrong direction, aren't I? Oh, now it's really gone. Entropy is the measure of the amount of energy which has been dispersed. So, a bunch of energy, losing as it falls down. Entropy is how much it's losing as it falls, and then the rest of it that's dispersed when it hits the ground. Energy, as it's going away, is the entropy until it hits the ground. Hopefully that'll make sense as we get a little further here. The rock is pushed off the edge of the cliff and lands on the ground. What happens to the energy? What happens to the entropy? Energy is conserved. It is the same before and after the rock falls and hits the ground. Entropy increases. The initial potential energy has been converted into heat, which is dispersed and less able to do work. After the rock has come to a rest on the ground, energy, entropy, okay, why or why not? Let's keep going. Although the total energy is conserved, much of that energy has become unavailable to do work. Entropy has increased. Let me see where we're at. We're on 40. Let's see how much time I have. Okay, we'll go about 5 more minutes, and then we'll look at the questions. There is no longer enough useful energy to do the work of lifting the rock back to the top. It would be impractical to use the dispersed heat to lift the rock. We refer to dispersed heat energy as being useless. Heat itself has uses. If you're cold, obviously it's going to warm you up. It is possible to build heat engines that are pretty efficient if they are designed to concentrate heat in a boiler before it disperses. But after the heat becomes dispersed, it is, for all practical purposes, useless. Within the universe, there is a constant amount of energy, a constantly increasing amount of useless energy, and a constant decreasing amount of useful energy. That's a mouthful. All right, I think we're going to stop there today.